China is home to some of the most structurally impossible hotels ever built. Buildings that shouldn't stand, shapes that shouldn't hold, designs that broke every rule engineers thought was unbreakable. Some of these structures took over a decade to complete and cost upwards of $4 billion, roughly the price of launching 6 crewed missions to the International Space Station. You heard that right. $4 billion, just to redefine what a hotel could be. These aren't places you simply sleep in. They're proof that human ambition, when backed by the right engineering, has no ceiling. Now, it all starts in Macau. Macau's architectural playground. You've heard of Macau as a gambling capital, but step past the casino floors and look up, and you realize this city became something far more significant. It became the testing ground for some of the most daring hotel architecture on the planet. Architects weren't just designing places to stay, they were making statements. And the structural engineers behind them had to figure out how to make those statements stand. Start with the MGM Macau. From the outside, the building curves and bends like it's in motion, a wave frozen mid-crash into the skyline. That wasn't an accident. The curvilinear facade was a deliberate architectural choice, and it created an immediate structural problem. Curved buildings don't distribute load the way rectangular ones do. Every bend in the frame creates uneven stress points, and engineers had to design a custom steel skeleton that could absorb those forces without compromise. What looks effortless from the street took years of calculation to make safe. But the MGM Cotai pushed things even further. Here, the design called for massive geometric volumes that appear to shift and float above one another, stacked masses that seem to defy the logic of gravity. The engineering team had to treat each volume almost as its own independent structure, then connect them in a way that made the whole building behave as one. The tolerances involved were brutal. A miscalculation at any connection point, and the entire visual effect, that sense of impossible floating weight, collapses into something ordinary. Then came the Grand Lisboa, and ordinary was never part of the conversation. The tower rises in the shape of a lotus flower, its steel petals fanning outward as it climbs. Each petal is a cladding element anchored to a central core, and managing the vertical load through a form that widens as it rises required engineering solutions borrowed from aerospace-level structural analysis. It shouldn't look the way it looks, but it does. And then there's Studio City Macau, where engineers were asked to mount a fully functional figure-8 Ferris wheel between 2 towers, hundreds of feet in the air. Not beside them, between them. The dual-tower system had to be designed from the ground up to carry that lateral load, without transferring dangerous stress into either building. Macau set the tone. But nothing could prepare you for what one architect was about to attempt just a few miles away. The hotel that defies gravity. You think you've seen bold architecture. Then you walk up to the Morpheus Hotel in Macau, and everything you thought you knew about how tall buildings work gets quietly dismantled. This isn't a building that pushes boundaries. It's a building that erased them entirely, and the story of how it was built is unlike anything else in modern engineering history. The vision came from Zaha Hadid Architects. The brief was simple in words and terrifying in execution. Design a tower with no internal columns, free-form voids carved straight through the middle of the building, and a structural system that lives entirely on the outside. What they proposed was an exoskeleton, a diagrid steel framework wrapped around the exterior of the tower that would carry every load the building generates. No core columns hiding inside, no traditional skeleton, just an outer shell of intersecting steel doing all the work. Here's why that matters. In almost every skyscraper ever built, the structure is on the inside. The facade is just a skin. With Morpheus, that logic was flipped completely. The exoskeleton isn't decorative. It is the structure. Every floor, every wall, every interior space hangs off or connects back to that external steel web. The moment you understand that, the building stops looking like architecture and starts looking like a miracle. But this was just the beginning of the engineering nightmare. Those voids, 3 massive openings punched through the tower's body, weren't just aesthetic choices. They were aerodynamic decisions. Wind behavior around a solid tower is already complex. Wind behavior around a tower with holes in it enters a different category of physics entirely. Engineers ran thousands of computational simulations to understand how air would move through and around those voids, and then had to design the exoskeleton to handle the resulting forces without a millimeter of flex that wasn't accounted for. The steel itself had to be custom fabricated. The diagram geometry means no two connection nodes in the exoskeleton are identical. Every single joint was engineered individually. You're looking at a building where the structural components were essentially bespoke designed, modeled, and manufactured one by one, then assembled on site with the precision of a surgical procedure. The payoff is something you feel before you understand it. Standing inside Morpheus, the interior opens up in ways that feel physically wrong. Vast, column-free spaces that your brain keeps telling you shouldn't be possible at this height. Floors that seem to float. Views that cut straight through the building to the sky on the other side. It is, by every honest measure, the most structurally ambitious hotel ever completed. Zaha Hadid once said that there are 360 degrees of architecture. Morpheus is proof she meant every single one of them. But if Morpheus conquered vertical space, the next structure on your journey does something even stranger. It bends itself into a circle and rises straight out of a lake. Rings, lakes, and impossible foundations. You've seen buildings that defy gravity from above. Now imagine defying it from below, from underneath a lake. The next stop on this journey takes you to structures where the ground itself was the enemy, and engineers had to rethink foundation logic from scratch. The Sunrise Kempinski Hotel outside Beijing stops you cold the moment you see it. A perfect ring. Not a curved building, not an arc. A complete, closed circle rising from the landscape. And the first question any engineer asks when they see that form is the same one you're probably asking right now. How does a circular building actually hold itself up? A rectangular building distributes its load in straight lines down to the foundation. A ring has no straight lines. Every point of the structure is in a constant conversation with the points beside it, transferring load in a continuous loop. Engineers had to design a foundation system that could accept load from every direction simultaneously, and a steel superstructure that behaved less like a building and more like a massive structural ring beam, the kind of geometry you'd normally find in a bridge, not a hotel. But the tension didn't stop at the foundation. A circular plan creates enormous outward thrust at every point of the ring. Left unmanaged, that thrust would want to push the walls apart from the inside. The engineering team essentially had to pre-stress the entire structure building in counterforces that neutralize that outward push before the building even opened its doors. Then, the Sheraton Huzhou Hot Spring Resort takes everything you just learned and drops it into a lake. The horseshoe-shaped tower rises directly from the surface of Taihu Lake, its reflection completing the circle in the water below. It is one of the most photographed buildings in China, and almost nobody who photographs it stops to think about what's underneath. Offshore construction in a freshwater lake means pile foundations driven through water, silt, and unstable lake bed with no dry land to stage equipment on. Every construction vehicle, every steel beam, every concrete pour had to be coordinated from floating platforms. Wind loads hit the structure from every direction with no surrounding buildings to buffer them. And the curved horseshoe form meant once again that standard load calculations were useless from day one. The result is a building that looks like it grew out of the water, which, in a very real engineering sense, it did. And if water was the challenge there, the next hotel chose something even more extreme. It went underground entirely. Precision over drama. Not every impossible hotel announces itself with a roar. Some of them whisper, and that's exactly what makes them dangerous to overlook. The Puxuan Hotel and Spa in Beijing doesn't rise from a lake or punch voids through its facade. It sits in the heart of one of the world's most historically loaded cities, steps from the Forbidden City, and it does something arguably harder than anything you've seen so far. It earns its place without shouting. Here's why that matters structurally. Building in central Beijing means operating under some of the most restrictive construction regulations on Earth. Height limits, vibration controls to protect ancient neighboring structures, underground utility networks that can't be disturbed, material delivery windows so narrow they dictate your entire construction schedule. The engineering challenge at Puxuan wasn't about inventing new geometry. It was about achieving perfection within a box that most architects would find suffocating. The facade work alone required a level of material precision that bordered on obsessive, stone cladding panels, cut to tolerances measured in fractions of an inch, fitted together so cleanly that the joins nearly disappear. The structural frame behind that facade had to be equally exact, because in a building this restrained, a single misaligned element isn't hidden by dramatic form, it's exposed by it. But this was just the beginning of what precision-driven engineering could produce. The interior structural decisions at Puxuan were driven almost entirely by the guest experience, which sounds soft until you realize what it actually demands of an engineer. Column-free dining spaces, double-height rooms with floor-to-ceiling glazing, a rooftop that carries both structural load and the visual weight of an unobstructed Beijing skyline view. Each of those experiential choices maps directly onto a structural problem that had to be solved invisibly, so that the guest never once feels the engineering beneath their feet. That invisibility is its own kind of ambition. Anyone can build something that looks hard. Building something that looks effortless in one of the most constrained urban environments on Earth takes a different kind of engineering courage entirely. The Puxuan proves that restraint, executed at the highest level, is its own form of impossible. But if precision within constraints is one extreme, the next hotel chose the most extreme constraint imaginable and built straight down into it, buried in the earth. You've watched engineers battle lakes, rings, and restricted city centers. But nothing quite prepares you for a hotel that doesn't rise above the ground. It descends beneath it. 88 feet beneath it, to be exact. Welcome to the InterContinental Shanghai Wonderland. And the moment you understand what was built here, the word impossible stops feeling like an exaggeration. The site was an abandoned quarry on the outskirts of Shanghai. Most developers looked at that pit and saw a problem. One team looked at it and saw a hotel. The concept called for a structure built downward into the quarry wall, with guest rooms embedded into the rock face, an underwater suite sitting below the quarry's natural water level, and a waterfall cascading down the cliff beside the building. On paper, it reads like fiction. On site, it became one of the most complex construction operations in Chinese hospitality history. The first enemy was water. Building below the natural water table means constant hydrostatic pressure pushing against every wall, every floor slab, every foundation element. The waterproofing system installed at Wonderland wasn't a layer, it was a multi-stage engineered barrier designed to hold back water pressure that increases with every additional foot of depth. A single failure point anywhere in that system and the lower floors flood. The engineering team had zero margin for error. But this was just the beginning of the structural nightmare. The rock face anchoring presented a second category of challenge entirely. Guest room structures couldn't simply rest on the quarry floor. They had to be cantilevered and anchored laterally into the cliff wall, using rock bolt systems drilled deep into the stone. Engineers had to assess the geological integrity of that quarry wall section by section, because one unstable rock formation could compromise an entire floor of rooms. Then came the construction logic problem. Normal high-rise construction builds upward. You pour foundations, stack floors, work your way to the sky. Wonderland inverted that entirely. The team had to work downward, in a confined pit, with cranes operating at angles that standard equipment wasn't designed for. The payoff is a guest experience that exists nowhere else on Earth. You sleep inside a cliff. The water outside your window isn't a pool, it's the quarry's natural water body, held back by engineering you'll never see, but will always be standing between you and it. And if going underground was one extreme, the next hotel chose to disappear into the landscape entirely, but in a far more beautiful way, where the land becomes the hotel. There's a certain arrogance built into most hotels. They arrive on a site, flatten what was there, and replace it with something entirely new. The Banyan Tree Nanjing Garden Expo Resort chose the opposite philosophy, and the structural decisions that followed from that choice were as complex as anything built underground or underwater. The resort sits within the Nanjing International Horticulture Expo site, a landscape of valleys, slopes, and deliberate natural beauty. The design brief demanded that the buildings feel like they emerged from the terrain rather than landed on it. That sounds poetic. Structurally, it's a serious problem. When your building footprint follows the natural contour of a hillside, you lose the flat, stable base that makes standard foundation engineering straightforward. Every building cluster at Banyan Nanjing sits at a different elevation, on a different soil profile, with different load-bearing characteristics beneath it. The foundation strategy had to be customized cluster by cluster, some on shallow spread footings, some on deep piles, some using grade beams that followed the slope rather than fighting it. But the tension ran deeper than foundations. Slope sites generate lateral soil pressure. The ground itself pushes horizontally against any structure embedded in a hillside. Retaining systems had to be engineered into the landscape integration so seamlessly that guests walking the resort grounds never sense the invisible battle happening between the buildings and the earth pressing against them. The roof forms added another layer of complexity. Sweeping curved canopies that mirror the valley topography look stunning from above. But a curved roof that follows landscape logic rather than structural logic creates uneven load paths, points where forces concentrate unexpectedly, and where standard roof framing solutions simply don't apply. The engineering team essentially had to model each canopy as its own unique structural problem. The payoff is a resort where you genuinely cannot tell where the landscape ends and the architecture begins. The buildings don't compete with the Garden Expo site, they complete it. That harmony took more engineering intelligence than most dramatic skyline structures ever demand, because here, the goal wasn't to be seen, it was to belong. But belonging quietly was never going to be enough for the next project on your journey, because what comes next was built to be seen from space. The hotel, built like a spaceship. You've seen restraint, you've seen precision, you've seen buildings that whisper. The Chimelong Spaceship Hotel in Zhuhai has absolutely no interest in any of that. This is architecture that grabs you by the collar, a structure so theatrically massive, so deliberately overwhelming, that the engineering challenge wasn't just about keeping it standing. It was about making something this enormous feel intentional rather than chaotic. The concept is exactly what the name tells you, a spaceship. A disc-shaped megastructure elevated above the ground, ringed with themed towers, covering a footprint so vast that the entire complex reads less like a hotel and more like a small city that decided to have a personality crisis in the best possible way. The structural problem starts with that central disc. Elevating a massive horizontal form above the ground requires a transfer structure, a system of mega columns and deep transfer beams that catch all the load from above and redirect it cleanly down to the foundation. The heavier and wider that disc gets, the more brutal the forces at those transfer points become. Engineers had to design columns substantial enough to carry that load while still allowing the visual drama of the elevated form to read clearly. Hide the structure too much, and the engineering honesty disappears. Expose it wrong, and the whole composition falls apart. But this was just the beginning of the complexity. The theme towers surrounding the central disc each carry their own structural logic, curved facades, non-orthogonal geometries, and feature elements that exist purely for visual impact, but still have to be structurally justified. Every decorative fin, every sweeping canopy, every illuminated surface panel adds dead load that has to be tracked back through the system to the foundation. Wind behavior across a structure this wide and irregular required its own dedicated analysis. The disc form catches wind like a sail, and the engineers had to ensure that lateral forces, particularly during typhoon conditions, were distributed through the superstructure without creating dangerous movement at the elevated level. The payoff is a guest arrival experience that feels genuinely cinematic. You don't check into the Chimelong Spaceship Hotel, you dock at it. And that feeling, that specific, engineered emotion, was the whole point from day one. But if Chimelong was built to overwhelm with scale, the next hotel chose a different weapon, entirely pure, unapologetic opulence. Opulence as a structural brief. There is a version of luxury that hides its ambition behind understatement. Wynn Macau is not that version. From the moment the project was conceived, the design brief was essentially a challenge thrown directly at structural engineers. Make every square foot feel like money, and don't let a single column, beam, or support element get in the way of that feeling. That sounds like an aesthetic instruction. It is actually one of the hardest structural mandates an engineer can receive. Column-free ballrooms spanning over 30,000 square feet, curved facade elements that wrap the building in flowing lines requiring bespoke steel framing behind every surface, massive chandelier installations in atrium spaces that each weigh more than a loaded semi-truck, suspended from ceiling structures that also have to carry floor loads from the levels above. At Wynn Macau, the interior design team's wish list was essentially a catalog of structural nightmares delivered with a smile. The curved exterior was where the tension hit hardest. A flat facade is structurally forgiving, a curved one is not. The framing system behind Wynn Macau's exterior had to follow compound curved surfaces that bend in more than one direction simultaneously while still transferring wind loads and cladding weight back to the primary structure efficiently. Every panel of the exterior skin was mapped against a three-dimensional structural model to ensure that what looked fluid on the outside was properly supported on the inside. Then came the cantilever spaces. Restaurants and lounges pushed out beyond the building's footprint, suspended over open air to maximize views of the Macau skyline and harbor. Each cantilever required a backspan structure extending deep into the building core, a hidden counterweight system that most guests will spend their entire stay completely unaware of, even as they sit at the edge of it sipping a drink. The payoff is an environment where the engineering becomes invisible in the most complete sense possible. You feel nothing but luxury, you notice nothing but beauty. And somewhere beneath your feet, inside the walls around you, and above the ceiling overhead, one of the most carefully engineered structural systems in Asian hospitality history is working in absolute silence to make sure that feeling never breaks. That is what separates a great hotel from an impossible one. And China, as you've just seen, builds nothing but the impossible. The people who made it possible. Every hotel you've encountered on this journey started the same way as a sketch that made engineers uncomfortable. A drawing that landed on a structural team's desk and was met with silence, followed by the slow realization that nobody had ever solved this particular problem before. That moment, repeated across dozens of projects, across decades of construction in China, is where the real story lives. The architects get the headlines. Zaha Hadid, the firms behind Macau's skyline, the visionaries who drew circles rising from lakes and hotels descending into quarries. But behind every one of those drawings was a structural engineer who looked at the geometry, looked at the physics, and decided that impossible was just an engineering problem without a solution yet. What changed everything was computation. The moment structural teams could model a full exoskeleton diagrid in 3 dimensions, simulate wind behavior through a voided tower, or map load paths through a ring-shaped foundation in real time, the gap between what architects could imagine and what engineers could build collapsed almost overnight. Morpheus doesn't exist without computational modeling. Neither does Wonderland. Neither does the horseshoe rising from Taihu Lake. But the software only goes so far. At some point, every one of these buildings came down to human hands, workers drilling rock bolts into a quarry wall 88 feet underground, steel fabricators producing bespoke connection nodes for an exoskeleton where no 2 joints were identical, construction teams operating cranes from floating platforms in the middle of a freshwater lake. The technology enabled the vision. The people executed it with a precision that left no room for error and no tolerance for ordinary. That is the truth behind every hotel on this list. Not just that they were designed boldly or engineered brilliantly, but that somewhere in the process, a team of people decided that the version of this building that was easy to build wasn't worth building at all. They chose the harder thing every single time. And what you're left with is a collection of structures that don't just redefine hospitality, they redefine what human beings are capable of building when they simply refuse to accept the limits in front of them.